Hello everyone, how's it going? My name is Dan the Tutor, on a quest to become the world's greatest tutor. In today's video, we're going to talk about how to find molar mass in chemistry and how we can use it. So first of all, molar mass can be found on the periodic table. Every element has a molar mass. You can find its number on the periodic table. It's the number that has the long decimal next to it. And basically what we use molar mass for, we use molar mass when we want to go between grams of a substance to the number of moles. And moles are important because that's the unit we use for everything that has to do with chemical reactions. So it's very important that we know how to go back and forth between grams and moles using the molar mass, which the formula for molar mass in general is capital M equals little m over N, where M is your molar mass, little m is your regular mass in grams, and then N is your number of moles. The abbreviation for moles is MOLS. You just take out the E and you have moles. So let's do some questions now with molar mass, starting with this first one. Find the molar mass of H2O. So here's all I have to do. First, I open up my periodic table and I look at the molar masses for both hydrogen and oxygen individually. Usually I like to round it to 3 decimal places, but really you should do whatever your teacher or professor says. So that means hydrogen is 1.008 and oxygen is 15.999. Now, since there's 2 hydrogens, that's why it's H2O, there's 2 hydrogens, I have to multiply 1.008 times 2, which gives me 2.016. And then to find the molar mass, I just have to add 2.016 plus 15.999. And that'll get me 18.015, and the units are grams per mole. And there's the answer for that first one. See, not too bad. But now for the second one, it's going to be a little bit harder. Find the molar mass of CaNO3-2. So as you can tell, there's a lot more elements here, and we got the parentheses with the subscript 2 on the outside. So we have to talk about what all this means. So first, let me write the 3 elements down. Ca, calcium, N, nitrogen, and O, oxygen. And let's write down the 3 molar masses for those from the periodic table. Calcium is 40.078, nitrogen is 14.007, and oxygen, again, is 15.999. And now I got to count how many of each element there are. So as we can tell, there's only 1 calcium. So that just means 40.078 is going to stay the same. Nitrogen. So this little 2 out here means distribute the 2 to both the oxygen and the nitrogen. In other words, there's going to be 2 nitrogen. So I have to multiply that by 2. And then for the oxygen, I got to do 2 times 3 because there's already the 3 there, and I got to distribute the 2. So 3 times 2 is 6. That means I have to multiply 15.999 times 6. And so if I plug both of these in my calculator, I'll get 28.014 for nitrogen and 95.994 for oxygen. And then finally, I just add these 3 numbers together, 40.078 from calcium plus 28.014 for nitrogen plus 95.994 for oxygen. And we'll get a final answer of 164.086. And again, the units are grams per mole. And there we go. That's the end of that problem. So now I bet we're pretty good at finding molar mass. But now the question still remains, what can I do with molar mass? Well, let's talk about that in this third example. Number 3, how many moles are in 20.1 grams of Na2SO4? So in other words, I gotta go from grams to moles. And the way we do that is you just have to remember the equation for molar mass, M equals little m over N. I gave us the mass. The mass is 20.1. I want to solve for moles, N, but I gotta find the molar mass. And to do that, we gotta find the molar masses of individually Na, S, and O, which I'll do right now. Sodium is 22.990. S sulfur is 32.065. And oxygen shows up again. Oxygen and hydrogen are both very popular. Oxygen 15.999. And going back here, remember I have 2 sodiums, Na, and 4 oxygens, and only 1 sulfur. So in other words, I got to multiply sodium by 2, and I got to multiply oxygen by 4. So that's going to be 45.98 for the sodium, and 63.996 for the oxygen. And the 32.065 for the sulfur is going to stay the same. So then to find the total molar mass, just add these 3 numbers up again, and we'll get a final answer of 142.041. So since that's the molar mass, I'm going to plug that in this equation right here. 142.041 equals the mass, which we said from the beginning was 20.1 grams. So 20.1 divided by n, the number of moles. If I want to solve for n, it means I multiply both sides by n, and then we'll divide by 142.041. So 20.1 divided by 142.041. And I get 0.1415, but since 20.1 is only 3 sig figs, I got to stop at 3 sig figs. So that means I'm rounding to 0.142, and that's moles, and that's going to do it for this third one. And now we just have one more example today. I encourage you to try this one on your own. What is the mass of a 1.01 mole sample of CaCOH? So go ahead, pause the video, try it on your own, and when you're ready to see the solution, unpause the video. Okay, so again, we're using the equation molar mass equals mass m over n, but I know n is 1.01. So now I just got to find the molar mass again, which the elements are Ca, C, O, and H. Calcium we already did today. It was 40.078. Carbon is 12.011. Oxygen, our favorite, 15.999. And hydrogen, 1.008. And we notice here this time, CaCOH, there's no subscripts, no nothing. So that means 1 of everything. So if I want the molar mass, I just have to add these 4 numbers together. And that'll get me a molar mass of 69.096. So once I have that, I just plug it into the equation I was making earlier. And this time I want to solve for little m, which is the mass. So I'm just going to multiply both sides by 1.01, and that'll get me 69.79. But remember, if I'm rounding to 3 sig figs, because that's how many 1.01 is, 3 sig figs, the final answer is 69.8, and that's grams. And there's our answer. So that's going to do it for this video. If you have any questions, please post them in the comments. Thank you all for watching. Have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.